my dear KCET 2025 aspirants. So I hope all of you are preparing really well for your KCET examination, and we have already completed the one-shot lectures for all the PU2 chapters, and now we are going to start for PU1 chapter. And the first chapter that I have picked up is very important and a very basic fundamental chapter, that is your general organic chemistry. Okay, that is chapter number 8, some basic principles and techniques in organic chemistry, that chapter. So yes, I will be discussing only those things which is required for this particular exam. Otherwise this chapter is a very big chapter and we don't have that much time as well to complete. So I will be covering the most important topics. So if you do this particular one video and solve some questions, I will also be doing some 40 questions in this video. I'll try. So if we solve these questions and try doing these chapters, these lectures, then you can solve any question that comes from this lecture. Okay, so coming to now here the topics that I am covering today. So first we'll be talking about the nomenclature, then isomerism, electronic effects. Okay, so it's means your inductive effect, these are effects. Then we'll be talking about intermediates, purification techniques and quantitative analysis. Okay, here if you know those methods, how to calculate the amount of chlorine present, bromine present, these all things we will be doing. Formulas you have to just remember. Here nothing much, very easy topic this one. From here to here is little bit where we have to focus on. Now coming to the first thing, that is weightage here. So you can see only 1-2 questions you can expect, but as I said, this chapter is very basic to solve the other organic chemistry questions. So you must pay full attention and focus to this particular chapter. Okay, this is a fundamental chapter. Okay, so before proceeding, I want to tell you that to crack any exam, okay, how much you study, more than that, something if it is important is question practice and attempting the mock test, right? So to help you with this, we have come up with our Abhyas KCET 2025 test series, the best test series that is available in the market at a discounted price of just ₹1498. Okay, so now in this you will be getting 35 mock tests, which includes both part test and full length for covering the subjects physics, chemistry, maths, bio from PU1 and PU2 syllabus. Okay, apart from that, you will also be getting one-shot revision videos, doubt clarification, live classes and detailed video solutions with complete explanation. So we had a live doubt clarification yesterday, like just 1 or 2 days before. Those students who have paid, they have come, they have asked so many doubts, and it was a really engaging class. So if you want, so already 5,000 plus students have registered and purchased the test series, and they have already taken a step ahead for their preparation for top 1000 rank in KCET. So if you also want to boost your preparation, you can take this test series. The link is given in the description section. Please go there, click on the link and you will be directed to our page where you can buy the test series. Okay, so this is very important. And one more thing, that is this test series is will give you an proper analysis of your accuracy, on which question, how much time you spend. So everything in detail you can get. It is a online test you will be able to do. So you will be able to access and your proper preparation level you can understand and improve it, right? So please do not miss this opportunity, and this is going to be a game changer in your preparation. Believe me, trust me, and purchase the test series. And the best part is, if you buy a test series and you get below 1000 rank, then you can get cash prize up to 1 lakh rupees. Okay, so we have different parameters. So if you get within top 100, you will get 1 lakh rupees, and if you get within 200 to 300, then 50,000. So the slabs are there that you have seen in all our videos. So that is there, but yes, minimum amount that you can win is 5,000, and 5,000 to 1 lakh it is there. So that is something you can see. Just investing of 1498 rupees, this is such a less amount. You can just spend this much in one day, in one dinner, right? So do not waste, do some investment for your better career, better opportunities. So please buy this test series. Okay, now moving forward to the first thing, that is our nomenclature. So from this chapter you can easily expect one or two questions which are based on nomenclature. Not only from this chapter, nomenclature can be asked from any chapter, right? So basic rules of nomenclature should be known. So the first rule is to identify the longest carbon chain. Okay, whenever chain is given, try to find out the longest carbon chain there. Okay, once you have found the longest carbon chain, you have to number the chain, and you have to number the chain in such a way that the substituents will get the least number. Now let me give you an example. Suppose I have a chain like this. Okay, so you can see that this is a chain. I can 1, 2, 3, 4, 5. This is a 5 carbon chain. 1, 2, 3, 4, 5, 6. So this is a 6 carbon chain. So which is the longest carbon chain I have identified? This is the longest carbon chain, right? Now you have to number them. So you can number it from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? Now if I number from this side, 1, 2, 3. I am getting the carbon which this is called as the substituent. The carbon which contains the substituent is coming at the third number. If I number from this side, it will come at fourth number. So you have to number it in such a way that the substituent will get the less number here. So definitely this is the correct way of numbering. Okay, so that is, you have to number the chain in such a way that the substituents gets the lowest possible number. Okay, now if there is a tie, prioritize the functional groups with higher precedence. So that I'll talk about when we know about the functional groups. Next, you have to identify and name the substituents. So when you are naming, first we have to write the substituent's name. Okay, so how will you write the substituent's name? They are used as prefixes, like for example methyl, ethyl, propyl, if anything is there. If the same substituent appears multiple times, use prefixes like di, tri, tetra, etc. Okay, so first we have to name the substituents, then we have to name the parent name, and then we have to name the suffix. So arrange the substituents in the alphabetical order. So whatever you have to first identify at what positions the substituents are there, and then you have to write the substituents with their position in the alphabetical order. I'll give you example, it will become clear. Okay, next you have to add functional groups as suffixes. So if the compound contains any functional group, for example if it is an alkane, the name will end with ANE. If it is an alkene, it will end with ENE. If it is an alkyne, it will end with YNE. Alcohol, OL, aldehyde, AL, ketone, ONE, carboxylic acid, oic acid. Okay. Next, assign priority to the functional group. So if there are more than one functional group, then you have to assign them priority, and the order of priority is carboxylic acid, then you have aldehydes, then we have ketones, then we have alcohols, alkene, alkyne, and alkane. Okay, so this is the priority order, and you have to use the prefixes for the substituent functional groups. Okay, I'll be telling you what prefixes are used. Next, double and triple bond indicate the position of double or triple bond in the chain using the lowest possible numbers. So this also with example will do. Now after the last thing, you have to combine the name. First will be the prefix where the substituents are written with their position in the alphabetical order. Then you have to write the root name based on the parent chain. So if it is 2 carbon chain, 3 carbon chain, 4 carbon chain. So if you know, for 1 carbon chain we use the word meth, for 2 we have to use the word eth, for 3 it is prop, okay, for 4 it is but, okay, 5 it is pent, 6 hex, 7 hept, 8 oct. Okay, so like this. So based, and then you have to write the suffix based on the highest priority functional group. So if there is more than one functional group, so whichever is the highest priority functional group, that name will end here. Okay. Next we have here nomenclature of alkanes. I will do examples. So let us do one by one. So you can see this one, this is a pure alkane. First we have to number it, right? So if I number from this side, it is 1, 2, 3, 4 and 5. So on second and fourth position I am having substituents, and the substituents are same substituent, it is methyl group. So what I will write, first we have to write the substituent's name. Before, when I write the substituent name, first I have to mention their position. So because it is same functional group, same substituent on 2 and 4, so I have to write 2,4 dimethyl. Okay, 2,4 it represents the position, di represents 2 methyl groups are there. 2,4-dimethyl pentane. So carbon, so this is your substituent part. Carbon chain, there are 5 carbons, so pent. It is a pure alkane, so name will end with ANE. Okay, no confusion here. Next, I have already numbered this one. You can see 1, 2, 3, 4, 5, 6, 7 carbons are there. Now on which carbons we have substituents? Check here. We have substituents on this carbon, 3rd carbon, 4th carbon, and on 4th carbon only we have 2 substituents, right? And on 3rd carbon I have a substituent of 2 carbon, which is a ethyl group, and on 4th I have methyl groups. So now I have to write the substituents name first, and obviously we have to write alphabetical order. So ethyl comes first, so it will be written as 3-ethyl. 3-ethyl. Then I have here 4,4-dimethyl. Okay, again it is on the same carbon, so 4, 4, 4, 1 4 for one methyl, 1 4 for another methyl, di represents 2 methyl, then 4, 4-dimethyl, and then the total number of carbon is hept, 4 carbons, so hept, and the name will end with ANE. Okay. Next, I have this chain. You can see here, if I number it, I'll get 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So here you can see 6th and 3 carbons are there. So on the 3rd position we have a substituent, on 6th carbon we have a substituent, right? So you can see that again 6th carbon is ethyl group, so I will write 6-ethyl, okay, 3-methyl, 6-ethyl, 3-methyl octane. Okay, next we have this big carbon. So first of all you have to find the longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see here any side you go it will become 9, but here if I am going that is 10. So definitely this is the longest carbon chain. Now if I want to see that on the 3rd carbon I have 2 substituents, right? 3rd, 4th, 5th, 6th, 7, 8, 9, 10, and on the 5th carbon this whole substituent is attached, right? And if you see, this substituent also has a substituent here which is on the 2nd carbon, right? So what I will name this one, or how to name this one, see carefully. So first I will write the substituent name which is present on the 5th carbon, right? So I will write here 5, okay. After that, so this shows that on the 5th carbon there is a substituent. Then on the 2nd carbon I have a ethyl group, and this one is a butyl group. So I will write 5, 2-ethyl butyl. Okay, 5, 2-ethyl butyl, and on the 3rd carbon I have 2 methyl groups. So next, okay, so this okay, see, this is the functional name here. The name is butyl group, and here it is methyl group. So definitely methyl will come after that, and it is on the same carbon. So 3,3-dimethyl is there. Okay, 3,3-dimethyl, and 10 carbons are there. So it is Dec-N. Okay, done. Fine. Next we have here nomenclature of cyclic compounds. So you can see here how to nomenclature cyclic compounds. So this is a 5 carbon cyclic ring, so you just have to name it as cyclic, just a minute, you have to name it as cyclopentane. Okay, cyclopentane. So here this I won't come, so it is cyclopentane. Okay, next if I see this one, 1, 2, 3. So here I have a methyl group, and here I have a propyl group, right? So your question may be as like, why can't I name it as 1, 2, 3? Okay, I can also name it like this, right? 1, 2, 3. But if this is happening, you have to see that the one which is alphabetically order coming first, okay, should be given least number. So this one is your methyl group. right? And this one is your propyl group. So M comes first, so M should be given the least number. So that is why this numbering will be wrong. 1, 2, 3 coming from that side is the correct order. Okay. So now if I see here 1, 2, 3, so it is 1 methyl, 3 propyl, cyclohexane. Okay. Next, okay, one more example here is there. Again, here a question is arising. You can see that this is a ethyl group, okay, and here it is a methyl group. Then if I follow that rule, then ethyl group is having lower alphabetical order, E comes first. So this should be 1, this should be 2, and this should be 3, right? But here again there is a difference. You see here, if I write, there are 2 methyl groups here, right? So what will be the substituents? You have to write 1, 1, 1 dimethyl, 3 methyl. But if I write number like this, what it will become? 1, 3, 3. Right? So whenever you have multiple substituents, the numbering of the substituents should get the least number. So if I just see here 3, 4, 5, this sum comes out to be 5 and this comes out to be 7. So always when you do the numbering of the substituents, when you add them, it should be a least number. So this number 5 should be the correct one. So that is why it has to be numbered in 1, 2 and 3. Okay. So numbering of substituents is very, very important. So I can write it as but I will write first ethyl group. Okay, while writing, the alphabetical order should be followed. So I will do 3 ethyl. Okay, then you have 1, 1 dimethyl. Okay, 3 ethyl, 1, 1 dimethyl cyclohexane. Okay, 3 ethyl, 1, 1 dimethyl cyclohexane. Next, here we have nomenclature of the functional groups. So alkanes it ends with A and E, alkenes it ends with E and E, alkynes it ends with Y and E, and arenes you have benzene and all like this. Then halides end with your, for example, you have to use the word, it is a prefix, bromo it used like halo like that. Alcohols, if it is a substituent it will be hydroxy, if it is a parent name it will end with OL. Next, aldehydes, if it is a substituent you can use formyl or oxo, formyl for aldehyde, oxo for ketones, and Al it will end with the, if it is a main functional group. Nitriles, it is cyano as if it is a substituent, nitrile if it is a main functional group. So you can see here pentane, nitrile, so 1, 2, 3, 4, on the 5th carbon you have the nitrile group. Okay, so now let's see some nomenclature of the benzene compound. So this is benzene, you have a methyl group, so methyl benzene. Here you have a methoxy group, so methoxy benzene. This compound is called as amino group, amino benzene or aniline. Okay, then here nitrobenzene, bromobenzene. Okay, this is very easy, just you have to write the substituent name and the benzene you have to add to that. Okay, so now let us see this compound you have to number. Okay, so numbering is the main thing. If you do mistake there, you will get wrong. So I can number it like this. So I have one option. So just a minute. Yeah. So I have one option to number it like 1, 2, 3 and 4. So if I number it in this way, what will be the order? You can see 1, 2 and 4. So the numbers that I am getting here is 1, 2 and 4. And if I number it in this way, okay, so if I am numbering it in this way, 1, 2, 3 and 4. So I am getting the substituents at 1, 3 and 4 position. 1, 3 and 4 position. So you know the addition should come less number. For 4, 5, 6, 7 here, 4 plus 3, 7 plus 1, 8. So this is wrong, this is correct. So I can remove this one. Okay, so I will remove this one. So I will get what? Now when you are writing, the substituent should be written in the alphabetical order. So chloro, then we have nitro, right? So I can write 1 chloro, okay, 2, 4 dinitro, 1 chloro, 2, 4 dinitro benzene. Okay. Next, if I see here this particular compound, again I have the same problem for numbering. I can try from this side 1, 2, 3, 4. Okay, I am getting 1, 3, 4. And if I try from this side, 1, 2, 3, 4. So I am getting 1, 2 and 4, right? And if you see in this way, if I am numbering 1, 2 and 4, I am getting less number, so that I have to prefer. But while writing, I have to write it in the alphabetical order. So definitely this will be 2 chloro. Okay, then I have after that methyl group, right? So methyl group will come first. So 1 methyl. Then we have 4 nitro benzene. Okay, fine. Next, the compound, okay, I have exceeded. Okay, this one I will write here. Okay, so it is already here number you can see. So 1, 2, 3, 4. If I number from this side, will 1, 2, 3, 4. So 1, 2 and 4 it is coming. So we have to follow that order. So this is called methoxy. This is methyl, right? And this is your chloro group. Okay, so how can we name that? So I can write it as 2 chloro. Okay, then if you see methoxy and methyl, right? So first this one will come 1 methoxy. Okay, 4 methyl benzene. Clear? Let's see the next one. Here also I have already numbered it. Okay, so here you can see this is amino, this is methyl and this is ethyl. So obviously ethyl will come first. So I will write 4 ethyl. Okay, then I have 2 methyl. Okay, 1 amino benzene. Okay, so this way you should do the nomenclatures. Okay, next if I see this particular one, here also I have already done the numbering. So here you can see OH is a main functional group. So the name can end with this one. So you can have 3,4 dimethyl, 3,4 dimethyl phenol. Okay, when you have benzene with OH group, that is called as phenol. So 3,4 dimethyl phenol group. Okay, so yes, this is what about nomenclature. I know we need to practice more examples, so don't worry, I'll give you questions and with those questions you can practice more. Okay, now we will talk about isomerism. So what is basically isomerism? Isomerism means where you have the same molecular formula but different structures or connectivity or patterns are possible, then we call it as isomerism. When I give example, it will be clear, but isomerism is of 2 types. One is your structural isomerism, another is your stereoisomerism. Now structural isomerism is again of 4 types that we will be studying here: chain isomerism, position isomerism, metamerism and functional isomerism. Chain isomerism, metamerism, positional isomerism and functional isomerism. Now stereoisomerism is again of 2 types. One is your geometrical isomerism and optical isomerism. So basically in our syllabus we have geometrical isomerism in detail, but I'll also be telling you about optical isomerism. So now coming to the first one, chain isomerism. Chain isomerism means different parent chain will be there. So for example, you can see, suppose I write I have a formula like C5H12. Okay, suppose I have a 5 carbon chain. So you can see I can write like this one compound where I have 5 carbons, just balance the hydrogens. I can have one where I have like this. So you can see here the parent chain is having 5 carbons, here the parent chain is having 4 carbon, right? But these 2 compounds will have the same formula, so that is called as chain isomerism. Next you have positional isomerism. Okay, so let me give you an example. Suppose I have a compound like this, OH group is attached here. Okay, so this is OH is attached on the first carbon. I can have another where the OH is attached at the second carbon. So you see here the position of the functional group is different. The carbon chain is here also 4, here also 4, but the position of the functional group is different, then we call it as positional isomerism. Next we have, okay, here you can see this is 1, 2, 3, this is second carbon, this is third carbon, and here we have 5 carbons, here also we have 5 carbons. So this is your positional isomerism. Okay, Next, if you see CHO group, here on the third carbon, there on the second carbon, again we have same CHO group, functional group. So this one will be again your, okay, when CHO group is there, the carbon has to start from here only. Okay, you might think that it is a positional isomerism, but you see, whenever CHO group is there, the numbering should start from there. So 1, 2, 3, 4 and 5. And here if I see 1, 2, 3 and 4. So this is 5 carbons and this is 4 carbons. So this is a chain isomerism and not a positional isomerism. Okay, be very, very careful here. Next, if I give you 2 chlorobutane and 1 chlorobutane, so you can see butane is same, that means the parent chain is same, the position of the functional groups is different. So it is which type of isomerism? Positional isomerism. Next, if you say write N-propyl alcohol, isopropyl alcohol. So N-propyl alcohol is this one, okay, isopropyl alcohol is this one. Again, here you can see that OH is present on the first carbon and here it is present on the second carbon. So this is also positional isomerism. Okay. Okay. Next, if you see here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 and this is 6 carbon. So the number of carbons are completely different here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So when the formula is different, then they are not isomers. Okay, this also you should remember that in isomers that the number of carbons should always be same. Now if you see here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, CN positions are different. So it will be what? Positional isomers. Okay. Now can we talk about this one? We have 2 carbons and Cl are on both the carbons. Here also we have 2 carbons but Cl are on the 1 carbon. Again the positions are different, so it is positional isomers. Okay. Now moving forward to next isomers, that is metamers. So metamers is a very specific and very easy type of isomers, I can say. Different arrangement of atoms and groups on either side of the functional group. So you can see that total we have 4 carbon here. This is a ether functional group. You have oxygen and this side 2 carbon and this side 2 carbon. But if you see on another structure here, I can draw that this side I have 3 carbon and this side I have 1 carbon. The total function is same, but besides the functional group, besides the oxygen, there are different number of carbons. These are an example of metamers. Similarly, if you see a ketone group, here you have 2 carbons, here we have 2 carbons, here we have 3 carbons and here we have 1 carbon. So I can write it like this. This is like this. Okay, so beside this CO group there is 2 carbon and this is 2 carbon. C3H7. So beside this CO group, here I have 3 carbon, here I have 1 carbon. Okay. Next, functional groups, different functional groups with the same formula. Suppose you can see this functional, this with this formula, that is C2H6O. Okay, here you can have one alcohol, you can also have a ether functional group. So the same formula but different functional groups are present, then we call it as a functional isomers. Next, here also you can see with this same formula, you can have an acid group, you can have an ester group as well, right? So acids and esters can have a functional isomerism. I hope this is clear. Next, moving to stereoisomerism. So stereoisomerism means they have same constitution and sequence of covalent bonds but differ in the spatial arrangement. So here in case of structural isomerism, the bonds are different. You can see here some different bond is formed and here some different bond is formed. But in stereoisomerism, the bond will be exactly same, but the molecule can have different arrangements in the space. And stereoisomerism is of 2 types, that is your geometrical and optical. Under geometrical, we have again 2 types, and I will also tell you how to calculate the number of geometrical isomers. So first, talking about the geometrical isomers. So what do you mean by geometrical isomers? When you have a double bond, okay, you cannot rotate the molecule. At that time we get geometrical isomers. So generally it is found in alkenes. Okay, remember, generally it is found in alkenes. So here we have an types, that is cis and trans and E and Z isomers. So what is this one? See, you have this group, okay, alkene. So first remember, for any geometrical isomerism, you need to have an alkene group, and this is A and this is B, right? So remember, this A should not be equal to B. This is very, very important. You must remember, A should not be equal to B. Okay, now if A is equal to B, then there is no isomerism, you can cross that one. So here you can see, first always when you check A and B whether they are equal or different. They are different, so definitely it will show the geometrical isomerism. Here also A and B are different. Okay, now here you see the same groups are on the same side, CH3 are on the same side, H are on the same side. So this type of isomerism we call it as cis. Okay, now here if you see, if it will be on the opposite side, then we will be calling it as trans. So we will see one more example. Okay, I will give you one more example for this one. 1 second. Okay, so now if I have a group like this, I have A here and I have B here, I have B here and I have A here. You can see AA on the opposite side and BB on the opposite side, then it will be called as a cis trans isomer here. Okay, clear? Fine. Next, if I go to this E and Z isomer, so in E and Z, what you have to do, I will be telling you with an example. So you see, here I have a carbon and here I have a carbon, right? So this side I have H and this side I have H, right? Just imagine like this. So this is CH3 group and this is an ethyl group. So what you have to do is you have to give the numbers to these two groups based on their molecular masses. So carbon is having more mass, right? Out of hydrogen and carbon, the one which is attached to the chain, carbon and hydrogen, carbon is having more mass. So here I will assign 1, here I will assign 2, right? Then here I will assign 1 and here I will assign 2. Now you see whether 1 and 1 are on the same side or opposite side. They are on the opposite side. So this one will be your E isomer. Okay. Now let's do one more here, 3. You can see this side bromine is having more mass, so 1, hydrogen is having less mass, so H, so that is 2. And here you see it is connected, when it is written like this, that means what? It is C double bond OH, right? When I am writing double bond O, you should think as like this, O and O. Okay, and here what is the bond? It is C, you have one H, you have one H and you have one O and then H. So now if I want to calculate, see this carbon is attached to carbon, this is also attached to carbon. Next this is attached to oxygen, this is also attached to oxygen. This is attached to hydrogen, this is also attached to hydrogen. Now here you see this is attached to hydrogen but this is attached to oxygen. So here this one will win, so this is 1 and this is 2. Now again 1, 1 are on the same side, 2, 2 are on the same side, so this one will be your Z isomer. Okay. Next, coming to fourth one, here it is oxygen 16 and 18. So isotopes of oxygen is taken. So definitely this is 1, this is 2, this is 1 and this is 2. Deuterium has more mass. Again 1 and 1 on the same side, 2 and 2 on the same side. So it is your Z isomer. Okay. Next here you see H and H are on this A is equal to B. So that means here no isomers or no geometrical isomers. Getting? Okay. Now coming to one more question here. So this is 1, this is 2 obviously. Here we have 2 carbons, so this is 1, this is 2. 2 and 2 opposite, 1 and 1 opposite, so it will be E isomer. Okay. Here if I see that you have CH2, CH2, after that here bromine, here oxygen. So bromine is having more mass, so that one will get more priority. So 1 and 2 this side, and this one CH2, CH3, here CH2, CH2 and then CH3. So here we have more mass, so this one will be 1 and this one will be 2. So again 1 and 1 on the opposite side, 2 and 2 are on the opposite side, so this will be your E isomer. Okay. Next, coming to the optical isomerism. Okay, now we will talk about optical isomerism. So what exactly you mean by optical isomerism? When a compound is there and it can rotate the plane polarized light, we call that compound as optically active. Okay, so what do you mean by optically active isomers? See, here you can see that you are giving a unpolarized light, then this is a polarized light. Okay, now here you have the sample, okay, inside this cylinder. When this light crosses this sample, it is rotated. right? So whenever any sample has the ability to rotate the plane polarized light, we call it as optically active compound. Okay, so now if a compound is given to you and asked that tell me whether it is optically active or not, then what you have to do, you have to go to the lab, you have to check, you have to put this device is called as polarimeter, so you have to keep in this device and you have to check, but that is not possible in the exam hall, right? So there's a condition that you should check to know whether a compound is optically active or not. So what is that condition? That condition is called as chirality or chiral center, and that means a carbon containing 4 different groups. So you know carbon valency is 4, it should contain 4 groups. If all the 4 groups are different in a compound, then if a compound is having any one carbon where all the 4 groups are different, then that compound or that carbon is chiral and that compound is optically active. I'll give an example here. So if this is not visible, let me draw it like this. Okay, and here I have methyl group. Okay, so if you say this carbon, it has H, so all the 4 groups are not different, so this is not chiral, this is not chiral, these carbons are not chiral. If I consider this carbon, here I have a methyl group, here I have a different group, here one hydrogen is present, and this side I have a different group. So this carbon is chiral. Similarly, if I check, this carbon is also chiral. So when in a compound we have a chiral centers, okay, then if I keep this molecule inside this sample and I pass plane polarized light, then the light will rotate, and I can call that this compound is optically active. Okay, clear? Fine. Next, okay, here also we have some more. You have to find E and Z. Let's do it first. So fluorine is having less mass, chlorine is more mass, bromine is less, iodine is less, 1 1 2 2 on the same side, so it is Z isomer. Next, if I see here, this is more mass, this is less mass, so 1 and 2. Here if you see more number of carbons, but here if you see like this, so this is C, see it is, you have, how can I say this one, when you are attached to a benzene ring, right, the structure is like this. Okay, that means what, this carbon is attached to carbon only, but here if you see this is attached to oxygen, right, so that's why here there is more mass, so 1 and 2 opposite side, so it is E isomer. Okay, here if I see, this is very simple, one, okay, the same groups there, so this is your trans isomer, this is not E and Z. And here if I see chlorine 1, this is 2, and here I have iodine 1, carbon 2, so 1 1 2 2 opposite, so E. Then here if I see CH3 same side, HH on the same side, so it is your Z, not Z, sorry, this is your cis. Okay, so if same groups are present, then we have to use cis and trans. If other groups are present, then we have to use E and Z, and that is the where you have to use 1 and 2 and then find out E and Z. Okay. Next, in geometrical isomerism, where I was talking about how to calculate the number of geometrical isomerism. So if the end group is different, that is unsymmetrical. Okay, just a minute. Yeah, so you can see here the number of 1 second. Okay, so if you have unsymmetrical carbons, means you can see 1 2 3 4 5 6 7 8 9 10 11, and you can see the end groups are different. Here you see there is CH2Br and here it is CH3. So when the end groups are different, then we use the formula 2 to the power of n, where n is nothing but the number of double bonds. Okay, so and if you find that the end groups are same, okay, when the end groups are same, then the formula becomes 2 to the power of n minus 1 plus 2 to the power of p minus 1. What is n and what is p? N is, if so, this n is your number of double bonds, right? So if n is an even number, okay, if n is an even number, then p will be equal to n by 2. If n is an odd number, then p will be equal to n plus 1 by 2. So let me take you this example and give you an example here. So we have n is equal to 3 here, right? N is equal to 3, so it is an odd number. So what is the value of p then? 3 plus 1 by 2, so that is 4 by 2 to that is 2. So now I have 2 to the power of n minus 1 and 2 to the power of p minus 1. 3 minus 1 is 2, 2 minus 1 is 1, so I have total 6 isomers. And here if I see, I have simply 2 to the power of 4, so that is 2 to the 4 to the 8, 8 to the 16. Okay, 2 to the 4, 4 to the 8 to the 6, total I will get 16 isomers here. Okay. So now students, we are going to go to the next part of this chapter, that is reaction mechanism. And in reaction mechanism, what all things we are going to discuss? First is what is reaction mechanism, fundamental steps in a reaction mechanism, bond cleavage and its types, then reaction intermediate, types of organic reaction, nucleophiles and electrophiles, and then I'll be also telling you about the electronic effects. Okay. So now if you see what is a reaction mechanism, a reaction happens, it happens in different steps. So when we talk about the steps, when we tell exactly what is happening there, so that is your reaction mechanism. So basically what happens, first a reactant and a reagent reacts to give you an intermediate. Now what is an intermediate? Intermediate is a short lived species. Okay, it is not the final product, but before the final product is formed, one intermediate is formed. Now this intermediate gets converted to the product. Okay. Now if you see the reaction mechanism, so there are basically two mechanisms. In the reactants what happens, the bond breaks, and in the products what happens, the bond forms, right? So now when the bond breaks, it is again of two types, heterolytic and homolytic cleavage. Okay, so heterolytic and homolytic cleavage, what is it? So if you have equal splitting of the bond, then we get homolytic cleavage, and this leads to the formation of free radicals. Okay, you will have one dot here, one dot here, this is your free radicals. Now in case of heterolytic cleavage, okay, it is unequal splitting of the bond and it leads to the formation of ions. Ions means cation and anion. So now if you see here, CH3Cl, this bond has 2 electrons. If one goes here, one goes here, then it is homolytic cleavage, equal cleavage, but that does not happen. Why? Because chlorine is more electronegative, it will pull the electron towards itself. So both the electrons will go here and we get CH3 plus and Cl minus. So one cation and one anion is formed here. Okay. Now if you see reaction intermediate, okay, so what is reaction intermediate? So reaction intermediate are the species that are formed in between the reaction. Okay, between the reactants and products we have the reacting intermediates, right? So now if you see carbocation, so carbocation are the positively charged species and carboanions are the negatively charged species. Okay, so and for example, if I have CH3 plus, this is your carbocation, CH3 minus, this is your carboanion. Next, free radicals means these are the neutral with an unpaired electron. So if there is a cleavage like this, CH3Cl, okay, this bond breaks like this and we get CH3 dot and Cl dot. Okay, so that is a free radical here. Getting? Now coming to types of organic reactions, so we have generally 3 types of reactions. Substitution reaction, which is very similar to what you have studied in other chemistry, like in your normal chemistry. Substitution reaction means one atom is replaced by another atom. Addition reaction happens when you have double bond. When you have double bond, what happens? When you add, it gets converted to single bond. So suppose I have this one, okay, and I added hydrogen here. So what will happen? This double bond will break, right? And we will get hydrogen addition here, right? So this is your addition reaction. Next, coming to elimination reaction. In elimination reaction, what happens? Single bonds get converted to double bond. For example, dehydration of alcohols. So if you have like this CH2OH, okay, now this H and OH is removed and here a double bond will form, that is dehydration. So we will get a product like this. Okay, so this is your elimination reaction. Now coming to nucleophiles and electrophiles. So what is a nucleophile? A nucleophile is something which has electron rich species. So for example, so this electron rich species can be negatively charged species or can also be neutral species. Okay, so for example, OH minus, NH3, H2O, Okay, so you see here they have lone pair, here NH3N has lone pair, here we have negative charge, you can have NH2 minus, right? So these all are your nucleophiles. Now what is electrophile? Electrophile are electron deficient species, or those species who are positively charged. Now if they are positively charged, example you have H plus, you have AlCl3. You can see AlCl3 is not having any charge here, right? But still it is an electrophile. Why? Because it is electron deficient. If you have remembered about the structure of AlCl3, it is like this, right? So aluminium has 1, 2, 3, 4, 5, 6. Total 6 electrons here, whereas a stable atom should have 8 electrons. So that is why, because of its electron deficient, it is a Lewis acid, or it is a electron deficient species, so it is an electrophile. You can have example of BCl3 also, right? So these are the certain examples for electrophiles. Now coming to electromeric effects, the first effect. So what is the role of this electromeric effect? So these electromeric effects discuss, or they help to decide the stability of a intermediate. So what is basically electromeric effect work? It is used to predict, okay, it is used to predict the stability of intermediates. We have seen 3 intermediates like carbocation, carboanion and free radical. So how stable is an intermediate, that is determined by these electromeric effects. So what are the electromeric effects we have? We have inductive effect, we have resonating effect, and we have hyperconjugation effect. Okay, these are the major effects that you should be knowing. So first of all, when I am saying that inductive effect, so inductive effect you should be knowing that it is applicable only in case of sigma bonds. Okay, so when the polarization of sigma bond due to the electronegativity of the atoms or groups attached to the chain. Now for example, if I have this CH3Cl, okay, here these electrons are present. Just now I told you chlorine is more electronegative. So what will happen? These electrons will move slightly towards chlorine. So here a slight delta negative charge and here a slight delta positive charge is developed, and that is nothing but your inductive effect. Now what are the features of inductive effect? It only operates on sigma bond. Next, it weakens with the distance. Like for example, if I have a long chain carbon like this, okay, so this one will pull this electron, so I will have delta minus here and I will have delta plus here. Now because it is plus, these electrons will also be attracted, so here also some positive charge will develop. But here the positive charge will be more, here the positive charge will be less. As we move further, the effect of inductive effect decreases. Next we have permanent effect. So when the molecule, as long as the molecule is there, there will be inductive effect. So there will be no time when this effect is not there. It is available every time whenever there is electronegativity difference between the atoms. Okay. Next, types. So you have minus I effect and plus I effect. Now when the electron is taken away from the carbon, okay, if the electron is taken away from the carbon, then it is called minus I effect. Okay, you can see the example, you have NO2, CN, COOH, these are all your minus I effect. Now plus I effect means when electrons are donated to the carbon. Okay, so for example, you have a carbocation and here you have a CH3 group. So this is positive, right? So these electrons will be attracted towards this side. The electrons present in this bond will be attracted towards the carbon. So it is a plus I effect shown by this group, means it is donating the electrons. If the same thing, if I have C plus and I have a chlorine group here, so what will happen? Chlorine will pull the electron because it is more electronegative. So it will be a minus I effect here. Okay, so here it is a plus I effect and here it will be a minus I effect based on the groups. So you have to remember the groups whether it is plus I or minus I effect. Okay. Next, the next effect is resonating effect. Okay, this is the most important and dominating effect. So what is resonating effect? Resonating effect, always remember, involves the delocalization of pi electrons or lone pair of electrons in a conjugated system. Now what is conjugated system? So there are two types of conjugated system, I'll tell you, please remember. So one is if you have double bond, single bond, double bond. This is one type of conjugated system. Or else the next one is if you have a double bond, single bond and then a carbocation. This is also a type of conjugated system. You can also have like this a lone pair, okay, then double bond, lone pair and then you have a double bond. Okay, this is also a type of conjugated system. So basically you should have a flow of, means this pi electrons or lone pair of electrons should be able to flow. So here this one can easily rotate, means it can delocalize. Here also this can delocalize. Here also these lone pair can delocalize. Okay, so these are the different types of conjugated system. If that is there, then the pi bonds or the lone pair of electrons can move along the molecule, and that is called as resonating effect. Now it occurs only with the alternating single double bonds. Okay, and it stabilizes the molecule, and it is also a permanent effect. Now types, so we have here minus R and plus R effect. So if it is an electron withdrawing group, if it is taking the electrons, for example, if I see, generally we talk electron donating and withdrawing in terms of what? Benzene ring. Now you see, I have a double bond, single bond and double bond, right? So what happens, because oxygen is more electronegative, it will pull the electron towards itself. Now this one will pull the electron towards itself. So from this ring, electrons are going away, right? So that is why it is called as a electron withdrawing group. Now if I have a nitro group, for example, if I have a NO2 group here, okay, now this one will, so again oxygen is more electronegative, this will pull the electron, this will pull the electron. So now this one is called as your, again what, this is your electron withdrawing group, right? So this is again minus R effect. Now coming to plus R effect is electron donating groups, increasing the electron density. So for example, you have here some OH group. Okay, now this OH group will donate electron, okay, and this one will donate electron. So because oxygen, see, now this lone pair of electrons can move towards the electrons here. So when the ring is giving you electron, when the electron in the ring is increasing, that is called as plus R effect. Now which all groups shows plus R effect? You should be knowing OH, OR, NH2, NHR, okay, then you have Cl, any halogen groups, these are all electron donating groups. Withdrawing groups, you have CHO, COOH, CO means your ketone group, then you have here you can also add methyl group, these are also electron donating groups. Next here we have NO2 group, CN group, these all are electron withdrawing groups or minus R effect. Okay. Next, coming to hyperconjugation. So hyperconjugation is the delocalization of electrons from a sigma bond to an adjacent empty or partially filled p orbital. So here what happens, you can see example, see here we have a because it is C plus, that means it has lost one electron. So this orbital is empty. So from the adjacent sigma bond, the electrons are transferred to this empty bond. Okay, that is called as your this is your hyperconjugation effect. Now it is very important for the stabilization of carbocation. So if you see here, the number of CH bonds are more here, so more number of electrons can be donated, so that is how it will stabilize this carbocation. It can also stabilize free radical and also alkenes. Involves no lone pairs or charges, so there is no involvement of lone pairs, only the sigma bond is donated to the empty p orbital of the adjacent carbon. Clear? Okay, now we will see some purification techniques. So we have here sublimation, crystallization, distillation. So I'll just crystallization is repeated here. Okay, once a minute. Yes, so we have then chromatography, you have solvent extraction, and then you have differential extraction. So don't have to go too much in detail. These three topics are the most important methods that you should be knowing. Chromatography as well. So what happens in sublimation? All of you know, when the substance directly gets converted from solid to gas, we call it as a sublimation process, right? So example is your mixture of sand and camphor, where you can see that sand and camphor will easily evaporate and it can be separated. Okay. Next is your crystallization process. So it is based on the difference of the solubilities of the compound and the impurities in a suitable solvent. So what you do exactly, first the impure solid is dissolved in a solvent. The solution is heated to evaporate most of the solvent. Okay, the solvent will evaporate. The hot solution is allowed to cool and the solid appears as pure crystals. So because the impurities are less soluble, so when you evaporate, so the impurities will remain behind, and when you cool you can find the impurities left behind. Okay, so that is the process of crystallization. Next we have distillation. So we have here simple distillation and fractional distillation. So generally simple distillation is used when you have a large number of the difference between the two solvents is very high. Okay, so it can be used for separating chloroform and aniline where the difference is almost about 100 Kelvin. Fractional distillation is very similar to simple distillation, but it is used when the difference between the boiling points is very less. Okay, now vapors of the liquid with higher boiling point condenses before the vapor of the liquid with lower boiling point. This is important. The one which is having higher boiling point will condense faster, and the one which is having lower boiling point will condense later. Okay, so this one you should remember. Next technique that I want to discuss is your chromatography. Okay, so in chromatography what happens, you have one stationary phase and one mobile phase. And how many types of chromatography? You have adsorption chromatography, that is TLC, and column chromatography, and then you have partition chromatography. So if you see the paper chromatography, I think all of you would have used it. You have to take a paper, then you have to put the drops, then you have to dip it in the solvent, then with the solvent the dyes or the water molecules, the substituent molecules will start moving, and you can see the distance that is covered by the different colors. So generally it is used for dyes, to separate the dyes of the plants or pens. Like that you can use this technique. Next one is your thin layer chromatography. The same thing is there, but instead of paper you use a TLC plate, or that is called thin layer chromatography. Generally it is made up of a silica plate. Okay, so they are the same thing, but here we use different material. Next we have partition chromatography. Again it is very similar to the previous mechanism, but here we use in a funnel shape, and you have the sample loaded, you have a stationary phase, and the samples you have a stationary phase and you load the sample here. Then the mobile phase, the sample keeps on moving here, and then it gets separated as it moves towards the down. Okay, so this is also a type of column chromatography. Then partition chromatography is like very similar to your separating funnel, where we use this one, and the solubility or the immiscibility is used, and they are separated in two layers. And using a separating funnel you can separate them, right? Next, solvent and extraction. So when an organic compound is present in an aqueous medium, it is separated by shaking it with an organic solvent in which it is more soluble than in water. Okay, so you have a impurity, or you have a compound, it is dissolved in water, then you add an organic solvent in which it is more soluble in the organic solvent. The organic solvent and the aqueous solution should be immiscible with each other, so that they can form two distinct layers which can be used or separated using a separatory funnel. So your compound has now come out to the organic solvent, right? It is not there in the water molecule. So when you do separating funnel, the organic compound goes to your organic solvent and it is separated there. So next, if we see quantitative analysis, so how can you calculate the amount of carbon, hydrogen, different compounds present in a given organic compound? So for that, the first one you should remember this formula: percentage of carbon is equal to 12 by 44 into M2 by M into 100, right? So here what is M2? M2 is, I'll write the values here, M2 is mass of CO2 produced in the reaction, okay, divided by 44. And what is M here? M is the mass of organic compound that you have taken. Now in the percentage of hydrogen, here M1 is the mass of water, okay, and this M is the I can say organic compound, mass of the organic compound, okay. Next we'll go to nitrogen. So nitrogen can be estimated using your Dumas method and Zeldal method, but especially the Zeldal method is more important, or from here the more number of questions are asked. So you can see the formula here for Dumas method. We have so for Dumas method we have 28 into V into 100 divided by 20,000, 400 into the molarity, into the M. Here again M is the mass of organic compound, okay, and volume is the volume that you have used. You can find the volume here and then you can substitute here, okay. For Zeldal method, the formula is very simple. You can use this one, 1.4 into m into 2 into v minus v by 2 by m. So all these values will be given in the question, don't have to worry. The values will be given, you just have to substitute them and find the value. Okay. Next, coming to halogens, so percentage of chlorine you can find 35.5 by 143.5 into the weight of chlorine by weight of organic compound. Percentage of bromine is 80 by 188, iodine is 127 by 235. Similarly, you can do all the calculations, so you have to remember the formula. Okay. Next, for sulfate, you have 32 by 233 into m1 by m into 100. Okay. So what is here m? m1 is mass of barium sulfate. Okay, clear? Then coming to phosphorus, the percentage of phosphorus is 62 by 222 by m1 into m by 100. Again, what is m here? M is mass of organic compound. m1 is what? m1 is the mass of this Mg2P2O7. Mg2P2O7. Clear? Okay. So yes students, these are the important things that you must be remembering from this chapter, but overall the number of questions directly asked from this chapter will be less, and even in the last 10 years also there was no question from this estimation method, but still you can do such 1-1 numericals from these chapters and you can just be relaxed that even if such question comes, you are ready to tackle it. Okay, so that's all in this video and see you soon in the next class.